Hi, everyone. Welcome to day 2 of week 35. Your learning intention for today is to explain how genetic variations in a population increase some individuals' probability of surviving and reproducing in a specific environment. So if you'll notice behind me, we've got peppered moths, which we'll talk about throughout this lesson. Your agenda's on the left and your work due by Thursday is on the right. Be sure to complete the check-in for today. Your classwork slides 10, 11, and 14, the Edpuzzle on natural selection day 2, and your exit ticket for day 2 on slide 16. Friday homework support is from 9:30 a.m. until 11:30 a.m. I'm going to go to slide 9 since slide 7 is for the video and slide 8 has the instructions for the check-in. So natural selection, slide 9. Darwin did not know about genes, but he saw that variations were the key to how evolution works. He saw these variations in most species on the Galapagos Islands, including the finches. He knew that there was not enough food on each island to feed every finch that was born. Finches had to compete for food, and as the finches spread to different islands, some were born with random variations in their features and beak size. This helped the finches live longer and reproduce more. Beneficial variations were passed on to offspring. This idea here is the theory of evolution by natural selection that Charles Darwin, was basically the creator of, right? And so it's this idea that survival of the fittest, right? So the birds that were able to eat and find their food are the ones that are going to survive, and the ones that are able to eat and find their food and reproduce are going to survive even better. Slide 10. Natural selection is the process by which populations of organisms with variations that help them survive in their environment live longer, compete better, and reproduce more than those that do not have variations. Natural selection explains how Galapagos finches match their food sources. Birds with beak variations that help them compete for food live longer and reproduce more. And so what role do variations have in the theory of evolution by natural selection? So first, you're going to write, the theory of evolution states that. What does the theory of evolution state? And variations between organisms, what does that do to help the survival of some birds? Slide 11, it's having you watch this video here. You're going to watch the video and write 3 facts. Slide 12, this diagram shows the different food types based on their beak size and shape, right? And so last week we were looking at different bird beaks, and here you'll see that different types of birds with different beaks, they're able to access different types of food, right, depending on both their environment and what their beaks are able to eat, really. Slide 13, natural selection example. So here's another way to think about natural selection. So say you have a population of mice that's moved to a new area where the rocks are very dark. Due to natural genetic variations, some of the mice are black and other mice are tan. Now, some mice were eaten by the birds, right? And so which mice do you think the bird is gonna be able to see more easily against the dark rocks? Well, of course, it'll be the lighter ones, right? And so in this image, you have less of the lighter ones here because the bird was able to spot the lighter ones more quickly, right? Tan mice are more visible to the predatory birds than black mice. Thus, tan mice are eaten at higher frequency. more often, right, than black mice. Only the surviving mice reach reproductive age and leave offspring. Then we have mice reproduce, which give rise to the next generation, right? And so as time goes on, you're gonna have the mice reproduce, and because the black mice had a higher chance of leaving offspring than tan mice, the next generation contains now a higher fraction, a higher number of black mice than the previous generation. And so this continues, right, over time, and over time you're probably gonna end up with way more, if not all, black-coated mice. Slide 14, natural selection. You've got images here, right? You've got arrows to follow. Yum, green beetles, our favorite, right? And so here, they're all eating green beetles. And now orange beetles, since they're not being eaten, they get to reproduce. And then generations later, green beetles have been selected against, and the brown beetles, or they look kind of orange to me, have flourished, right? Because they weren't the ones that were being eaten. They're the ones that are able to survive and reproduce. So in your own words, describe why the orange beetles survived in relationship to what you've learned about natural selection. Orange beetles, I should say brown. The brown beetles, they call them brown beetles, they look orange, survived because, well, let's be consistent here. The diagram, or orange. I think they look orange, but the diagram says brown. So we'll call them brown or orange. Okay, there you go. Why were they able to survive? Slide 15. Recall, evolution can most simply be described as change over time. After Darwin returned home to England, Darwin continued to think about what he had seen during his voyage on the Beagle, the ship that he used to sail the world and explore, right, as a naturalist. Darwin spent the next 20 years consulting with many other scientists, gathering more information and thinking through his ideas. Perhaps, Darwin thought, that species gradually change over many generations and became better adapted to new conditions. The gradual change in a species over time is called evolution. Darwin's ideas are often referred to as the theory of evolution. A scientific theory is a well-tested, right? So here's another term. A scientific theory is a well-tested concept that explains a wide range of observations. And so only the organism with a desired trait will survive and reproduce, right? We have that example about the giraffes. If you had a group of giraffes, a population of giraffes, some tall, medium, and short giraffes, but food, if it was only available at a high height, then the ones that are taller, the ones that are going to survive and reproduce. And over time, you're going to get a higher population of the tall giraffes, right? So it's over time, your population is growing, not the individual organism. Slide 16, you're going to watch the video below, and then describe the evolution of peppered moths by natural selection. So behind me are peppered moths, right? You'll notice some of them are dark, some of them are light, some of them have a dark background, right? Some of them have a whiter background. And so this is something to think about when you're thinking back to the Industrial Revolution. So in your exit ticket, you were going to fill in the blanks here based on what you learned from this video. In the 1800s, which event took place? The burning of coal produced blank. Since industrialization changed the environment, the dark colored moths, and then you can type your answers there. What happened to them? What happened to their population? Did they survive more? Did they not? And the light colored moths, what happened to them? Did they survive more? Did they not? And why? Okay, when you're finished with all of your classwork slides, be sure to turn this in. Otherwise, I will see you next time. Bye-bye.